This short video goes over 2016 number 4, part C. I want to talk to you about L'Hopital's rule here. We're trying to find the limit as x approaches -1. If I plug -1 into g, obviously I get 2. So the numerator is going to be 2 minus 2, which is 0. If I plug -1 into the denominator, I also get 0. Now, traditionally, what I've had you do is write this curly bracket, and we would say 0 over 0. We are never allowed to say equals 0 over 0, but I got around that by putting this curly bracket and saying 0 over 0. Now, I've asked people who have scored AP, and I said, is that okay? And their response is always, I'm not sure. To be certain that we express L'Hopital's rule, what we're going to start doing this point forward is saying the limit as x approaches -1 of g of x minus 2. We know that that's going to be equal to 0, and separately the limit as x approaches -1 of 3 times the quantity x plus 1 squared is also equal to 0. So we are going to do this now instead of this, although I'm not 100% sure it's not okay to do this. So I'm just going to stick with whatever I'm 100% sure with. And now, because of that, we're going to employ L'Hopital's rule, which is derivative over the derivative. And we showed earlier that g prime of -1 is equal to g prime of -1 comma 2 because it depends on x and y, which is going to be -1 squared minus 1/2 times 2, which equals 0. So now, once again, since we're going to have 0 over 0, we're going to say the limit as x approaches -1 of g prime of x equals 0, and in a separate statement, the limit as x approaches -1 of 6 times the quantity x plus 1 equals 0. And since that is true, we're going to employ L'Hopital's rule, which is the limit as x approaches -1 of derivative over derivative. And now we can evaluate g double prime at -1, which I've done the work down here, is going to equal -2. So this is going to be -2 over 6, and we can reduce that to -1/3. So in summary, never, 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 never say equals 0 over 0. You may get away with saying 0 over 0 in brackets, I'm not sure, but you definitely will get full credit if you write the separate limit statements from the fraction followed by the L'Hopital's process.